In this video we're going to continue with differentiation once again, and we're still learning to prepare to differentiate. So example 6, a function f is defined for x in the real numbers and x not equal to 0 by f of x equals x over 5 plus 1 over x squared. Find f dashed of x. So firstly we can actually express this as a fifth x to the 1 plus x to the negative 2. So we can see here that the fraction is a fifth and then we're multiplying that by x, and here 1 over x squared is the same as x to the negative 2. Now differentiating this, f dashed of x will be equal to 1/5, and x to the negative 2 is the same as negative 2x to the negative 3. Again, we've got a negative index there, so we can express that with a positive index by expressing it as the 2 over x cubed. So our derivative, f dashed of x, is 1/5 minus 2 over x cubed, which is our final answer here for example 6. Now example 7, we want to differentiate x to the 4 minus 3x squared all over 5x with respect to x. Now again we've got a fraction here involving algebraic terms, so we need to somehow simplify that before we differentiate. We also don't have y equals or f of x equals, so we are employing Leibniz notation again. So d by dx of x to the 4 minus 3x squared all over 5x. Now because there is a single term on the denominator, we're able to divide each of the terms in the numerator by that single term. So you can see here we've got x to the 4 over 5x minus 3x squared over 5x. And we're able to simplify that. We get x cubed over 5, or a fifth x cubed, minus 3/5 x, or 3x over 5. So you can see there the different ways that we can write the same thing. We are now ready to differentiate. So it's d by dx of a fifth x cubed minus 3/5 x, and differentiating that gives us 3/5 x squared minus 3/5, which is our final answer there. So making sure that we get single fractional terms which don't have algebra within the fractions as such, that the algebraic terms are either on the numerator or they're written as a multiplier here, and then we can differentiate more easily. Okay, just now would be a good time to pause the video and copy this down in your notes jotter. And now we'll look at example 8. So find the derivative of y equals root x multiplied by x squared plus a cubed root of x with respect to x. Now, you can see here we've got brackets, we have radical signs everywhere, so we really need to simplify this first. So if we firstly express this with all indices instead of radical signs, we get y equals x to the half multiplied by x squared plus x to the third. Now, I'm going to employ the grid method here to make it easier to expand that bracket. So x to the half multiplied by x squared. So remember, when we are multiplying terms with the same bases, that's x, we can add the powers together. So we would get x to the power 2.5, which as an improper fraction is x to the 5 over 2. And x to the half multiplied by x to the third gives us x to the 5/6. So we can express y as x to the 5 over 2 plus x to the 5 over 6 here. So we are now ready to differentiate. So dy by dx will be equal to 5 over 2 x to the 3 over 2 plus 5/6 x to the negative 1/6. Now we have fractional indices here, which we need to express with radical signs. We also have a negative index here, so we need to deal with that as well. So dy by dx will be equal to 5 over 2 multiplied by the square root of x cubed, that's the first term there, plus 5 over 6 multiplied by the sixth root of x. So you can see we've moved the algebraic term onto the denominator here because of the negative index, and then we have removed the fractional index to express it with a radical sign. So it's the sixth root of x on the denominator, and that is our final answer. So it would be good to take this down in your notes before the screen goes blank.